Hello students, welcome to the subject of complex variable and partial differential equation. This is Dr. Ankit Acharya, and as you all know that in last lecture we discussed about how to find particular integral for homogeneous linear partial differential equation. So in this topic we have to see 5 cases. Okay, so this is our first case, case 1, f of xy that is equal to e raised to ax plus by. Okay, and we already discussed about this topic, this case 1, and we already discussed one example. So let's take a quick revision of this topic. So this is our case 1, f of xy that is equal to e raised to ax plus by, and 1 upon f of d dash e raised to ax plus by, which is our particular integral. Just you have to take, instead of d you have to take a, and instead of d dash you have to take b. Okay, but the condition is denominator must be non-zero. That means f of ab must be non-zero. Suppose f of ab is equal to 0, then what you have to do, you have to multiply with x. So x into 1 upon f dash ab. Make sure your differentiation must be with respect to d. Okay, not with respect to d dash, with respect to d. So x into 1 upon f dash ab e raised to ax plus by. That means you have to differentiate of f of d dash with respect to d, and then instead of d you have to take a, and instead of d dash you have to take b. And if you remember, then in last lecture we already discussed about this example. This is our first example, right? Okay, so let's solve one more example. So second example, solve the del cube z by del x cube minus 2 del cube z by del x square del y, that is equal to 2 into e raised to 2x. Let's see how we can solve. First you have to find complementary function, and then we find particular integral. And what is our general solution? General solution is nothing but z is equal to complementary function plus particular integral. So first of all, write f of d dash. So f of d dash, that is equal to d cube minus 2 d square d dash, that is equal to 0. Okay, now if we convert this auxiliary equation in m, so this is nothing but m cube minus 2m square, that is equal to 0, right? Where m is equal to, don't forget, m is equal to what? D by d dash. Okay, so this is nothing but m square. M square is a common in bracket. Now we have m minus 2, so m square into m minus 2, that is equal to 0. So that's why roots are, how many roots we have? 0, 0 and 2. Okay, so the complementary function that is equal to f1, because 0 is a repeated root, right? So that's why complementary function we write for 0, f1 y plus m1x plus x into f2 y plus m1x, right? But what is your m1? m1 is 0. So that's why f1y plus x f2y, okay, and plus, now for 2 we have to write f3y plus 2x. Clear? So this is my complementary function. Now we find particular integral. So what is your particular integral? 1 upon f of d dash into f of xy. What is your f of xy here? 2 into e raised to 2x. So that's why particular integral that is equal to 1 upon f of d dash. What is it? D cube minus 2 d square d dash into 2 e raised to 2x, into 2 e raised to 2x. Correct? Now using case 1, just you have to take, instead of d square, instead of d you have to take 2, right? And instead of d dash you have to take 0, because when we compare this function e raised to 2x, compare this function with e raised to ax plus by. So what is your a? A is equal to 2, and what is your b? B is equal to 0. Here compare e raised to 2x with e raised to ax plus by. So a is equal to 2 and b is equal to 0. So that's why instead of d you have to take a. So that's why instead of d you have to take 2, and instead of d dash you have to take 0. So definitely this equal to 1 by, this equal to 1 by 2 raised to 3 minus what is our function? Let me show you. 2 d square d dash. Okay, So minus 2 d square means 2 square, right, into d dash. So d dash means 0. Instead of d dash we have to take 0, so that's why 0. And now 2 e raised to 2x. Okay, so 2, right, 2 e raised to 2x. So this is 0, right, 2 raised to 3, that is 8. So 2 by 8 e raised to 2x. So final answer is 1 by 4 e raised to 2x. Okay, so what is your general solution? Z is equal to, we know that general solution is nothing but CF plus PI. So that's why, what is your CF? CF is nothing but F1y plus x into F2y, okay, plus F3y plus 2x and plus particular integral is e raised to 2x by 4. Clear? So this is my final answer. Let's solve one more example. 4r, now you know that this is standard notation, 4r plus 12s plus 9t, that is equal to e raised to 3x minus 2y. Okay, so we know that r is what? R is nothing but del square z by del x square. What is s? S is nothing but 12 del square z by del x del y. Sorry, what is t? T is nothing but del square z by del y square, right? So that is equal to e raised to 3x minus 2y. Now f of d dash, that is equal to 4d square plus 12 d into d dash plus 9 d dash square, that is equal to 0. Okay, now m square, right? So when we convert this equation in m form, so 4m square plus 12m plus 9, that is equal to 0, where m is equal to d by d dash. Don't forget what is your m. M is nothing but d by d dash. Now this is perfect square. 2m plus 3 whole square, that is equal to 0, correct? Okay, now so roots are equal roots. Roots are minus 3 by 2, minus 3 by 2. Okay, so what is your complementary function? The complementary function is that is equal to f1 y minus 3x by 2 plus x f2 y minus 3x by 2, because minus 3 by 2 are roots, equal roots. So that's why we have to write complementary function with this manner, right? So now we want to find particular integral. Okay, so particular integral is what? 1 upon f of d dash. So 1 upon 4d square plus 12 d dash plus 9 d dash square. And what is my function? E raised to, let me show you what is your function, e raised to 3x minus 2y. Okay, so that's why e raised to 3x minus 2y. So what is your a? A is equal to, what is your a? A is equal to 3 and b is equal to minus 2, correct? A is equal to 3 and b is equal to minus 2. Put a is equal to 3 and b is equal to minus 2 instead of d and d dash respectively. So if you can understand, see, when we put a is equal to 3 here, so this is 3 square, 9 into 4, 36, correct? Instead of d dash, when you put here minus 2, so minus 2 square, that is 4 into 9, 36. So this first term become 36, last term become 36. In the middle term become minus 72. Let me show you. 12 into 3 into minus 2. Okay, I hope you can understand. 12 into 3 into minus 2. So 12 into 3, 36 into minus 2. That is minus 72. So that means what? When you put a is equal to 3 instead of d and b is equal to minus 2 instead of d dash, denominator becomes 0, right? So you cannot take the value of a and b directly instead of d and d dash, right? So as you all know that, now we have to apply this rule. We have to multiply with x. So x, now differentiate of this function, right? 4d square plus 12d dash plus 9d dash square. Differentiate of this function with respect to d. With respect to d. So that's why 1 upon 8d, right, plus 12d dash into e raised to 3x minus 2y. Okay, I differentiate of f of d dash with respect to d. Now again apply the same rule. When you apply the same rule, instead of d, when you take a is equal to 3, and instead of d dash, when you take b is equal to minus 2, again you will get 0. Let me show you. 8 into 3, 24, and this is 12 into minus 2, minus 24. So again you will get 0. So same rule that you have to apply, again you have to multiply with x. So now you have x square. Okay, and differentiate of this function 8d plus 12d dash with respect to d. So that is 1 upon 8 only. Now there is no operator. Okay, e raised to 3x minus 2y. So that's why this is my final answer, particular integral. Now there is no operator. There is no d. There is no d dash in this equation. So this is my final answer, x square by 8 e raised to 3x minus 2y. So don't forget to write our general solution. Z is equal to CF plus PI, right? What is my CF? CF is nothing but F1 y minus 3x by 2 plus x F2 y minus 3x by 2. And what is my particular integral? Particular integral is x square by 8 e raised to 3x minus 2y. Am I correct? Let me show you. X square by 8 e raised to 3x minus 2y. This is my particular integral, and complementary function is f1 y minus 3x by 2 plus x f2 y minus 3x by 2. Okay. Let's solve one more example. Del cube z by del x cube minus 3 del cube z by del x square del y plus 4 del cube z by del y cube, that is equal to e raised to x plus 2y. Okay. So first of all, write f of d dash, that is equal to d cube minus 3 d square d dash plus 4 d dash cube, that is equal to 0. So m cube. Okay, when we convert this equation in m form, so m cube minus 3m square plus 4, that is equal to 0. So m is equal to d by d dash. Now I want to find the roots of this equation. M cube minus 3m square plus 4 is equal to 0. Now can you understand that first of all minus 1 is one of the root. Suppose when we take m is equal to minus 1, so minus 1 cube, that is minus 1, minus 1 square, that is 1. So minus 1 minus 3 minus 4 plus 4, that is equal to 0. I hope you can understand. So because this is a third degree polynomial, so for third degree polynomial, first of all you have to find out our one root, first root. Okay, first root that you have to find out. Okay, and m is equal to minus 1 is my first root, is one of the root. Okay, so minus 1 cube, that is minus 1. I hope you can understand. Minus 1 cube, that is minus 1. Minus 1 square, okay, that is 1. 1 into minus 3, so that is minus 3 and plus 2, that is equal to 0, that we know. Okay, so that means what? Minus 1 is one of the root. Okay, and now using synthetic division you can easily solve this equation. So first of all, the coefficient of m cube, that is 1. Okay, I am using synthetic division method, as you all know that 1. Then coefficient of m square, that is minus 3, coefficient of m, that is 0, and then constant term, that is 4. Okay, now minus 1 is one of the roots. So here I write minus 1, then I have to write 0. So 1 plus 0, that is 1. Minus 1 into 1, so that is minus 1. Minus 3 minus 1, that is minus 4. Minus 4 into minus 1, that is plus 4. 0 plus 4, that is 4. 4 into minus 1, that is minus 4. And 4 minus 4, that is 0. Here. So now what is my factorization? M plus 1, because minus 1 is one of the roots, so definitely m plus 1 is my factorization first, and then m square. This is the coefficient of m square, this is coefficient of m, and 4 is coefficient of 4 is constant term. So m square minus 4m plus 4, that is equal to 0. So that's why m plus 1, Okay, and this is m minus 2 whole square, that is equal to 0. So clearly roots are minus 1, 2, 2. Okay, roots are minus 1, 2, 2. Clear? And now we can write complementary function. Okay, f1 y minus x, f2 y plus 2x, and plus x into f2, f3 y plus 2x, because 2 is a repeated root. Now find particular integral. Okay, particular integral, that we know that 1 upon f of d d dash. What is your f of d d dash? F of d d dash is nothing but d cube minus 3 d square d dash plus 4 d dash cube. So d cube 3 d square d dash plus 4 d dash cube. And what is your function? F of xy is nothing but e raised to x plus 2y. So e raised to x plus 2y. That means what? What is your a? A is equal to 1 and b is equal to 2. So instead of d, you have to take 1, and instead of d dash, you have to take 2. So this equal to, first of all, 1 raised to 3 minus 3. Instead of d, you have to take 1. So 1 square. Instead of d dash, you have to take 2. So this is 2 plus 4 into 2 raised to 3 into e raised to x plus 2y. Okay, so now easily you can simplify. This is 2 raised to 3, so that is 8. 8 into 4, so that is 32 plus 1. Okay, so that is 33, and this minus 6. Okay, so 27. So the final answer is 1 upon 27 e raised to x plus 2y. Okay, and just write our general solution. I hope you can understand the general solution. Z is equal to complementary function plus particular integral, so that you can easily write down complementary function plus particular integral. So Z is equal to f1 y minus x plus f2 y plus 2x plus x into f3 y plus 2x plus 1 by 27 e raised to x plus 2y. So in today's lecture we discuss about case 1 for particular integral. Case 1 is nothing but how we can find particular integral if your function f of xy, that is equal to e raised to ax plus by, and we solve so many examples related to case 1. So thank you.